My name is Edward Stevens, and this is my Lab 3 Magnetic Field of a Bar Magnet lab. In this lab, we were tasked with measuring the strength of the magnetic field of a bar magnet at different observation locations around the magnet. To do this, we set up a bar magnet on a table and used our phone's magnetometer with an app to measure the strength and direction of this magnetic field at different locations induced by the bar magnet. To compute these values, the theoretical ones, we would use the Biot-Savart law. In this lab, we used four main fundamental physics concepts. Firstly, the Biot-Savart law that was used to calculate the magnetic moment for each observation location. The right-hand rule that helped us determine the direction of the magnetic field at each location. How magnetic dipoles work and how we can calculate the direction and magnitude of a magnetic field at any point in space. And the magnetic field of magnetic dipoles at some point away from the magnet on axis. This is my procedure and observation slide. For our procedure, we first positioned our phones on the table in a way where the x component of the Earth's magnetic field was equal or as close as equal as we could get it to 0. This was tough to do because around the table there were many things like charging blocks that were embedded in the table that induced a magnetic field in the phone's sensor, so we had to raise the sensor up off the table with some foam blocks. Next, we had to find the position of the magnetometer within our phones. We did this by moving the magnet around and seeing where the arrow on the screen would swing around in a circle when moving the magnet in a tight circle near the phone. Then, we had to measure the distance from the magnet to the phone for each of the separate magnetic field requirements. This involved measuring the distance and then seeing what the magnetic field's value was for each distance and repeating the steps 3 times and recording the data. When we saw that our magnet got closer to the magnetometer, the x component of the magnetic field increased, and when the magnet got far away from the sensor, the magnetic field in the x direction approached 0. In my data collection and calculation slide, you can clearly see where I have recorded for each distance the Tesla recorded by the phone's magnetometer for each trial that we conducted. For each trial, we did 3 different tests and recorded the data, and the spreadsheet automatically plotted the data in the graph to the right. On the left, you can see the data taken from the graph and the magnetic moment that was calculated from the data given. In the coding section, I was tasked with creating a code that can simulate the effects of a magnet in space with its magnetic field. The vectors in the picture that you see, the blue, orange, and green ones, are the different observation locations that we needed to find the direction and magnitude of the magnetic field for the bar magnet. In the bottom, you can see the code that draws the arrows by calculating the direction and magnitude of the magnetic field at each point. The what if slide first asks, what if we hadn't oriented the experiment to compensate for magnetic north? Well, the experimental data in our experiment would be off because the x component of the Earth's magnetic field would be included in our calculations, thus making them not exclusive to the bar magnet. And secondly, if we were to stick 2 identical magnets together end to end and run the experiment, how would the results differ? The magnetic field would be larger, however, the overall shape would remain the same.